Hello friends, in this session we are going to understand something which is called as rheostat. Now this rheostat is also called as variable resistance, right? And this can be used as current controller and potential divider. It can be used as what? Current controller, or it can also be used as potential divider. Okay, so let us understand something which is called as rheostat. Okay, now we'll start with an example. Let's say, for example, I am having a battery which is connected to set of resistors, 5 resistors. 1, 2, 3, 4, 5. Right? The EMF of this battery E is equal to 10 volt. Right? Resistance R1, R2, R3, R4, R5. Right? Okay. The resistance, currently what we are assuming that the resistance of this resistors is the same, which is equal to 2 ohm. So this is also what? 2 ohm, 2 ohm, this is also 2 ohm, 2 ohm, 2 ohm. Right? Okay. In this particular case, if the resistance is 2 ohm, what would be the current which is flowing inside the circuit? Right? So, according to Ohm's law, V is equal to I into R. So, in this particular case, what is the potential difference across the battery? E is equal to I into the total equivalent resistance. So, equivalent resistance will be what? R1 plus, R2 plus, R3 plus, R4 plus, I5. So, it is 10 is equal to I into 2 times 5 times 2, it comes to what? 10. So, I is equal to what? 1 ampere. So, in this particular case, the current is 1 ampere. Right? Okay. However, if I want that 5 ampere of current should flow through the circuit, what I want? I want 5 ampere of current to flow through the circuit. Then what will I do is, I'll simply disconnect this particular part. I am disconnecting this particular part and connecting this wire to this resistor. Let me name the points. This is point A, point B, point C, point D, point E, and point F. So what I have done, I have disconnected the wire and connected the resistance and connected the same wire at this particular point, right? At this point. Okay. Now, what about these resistors? R2, R3, R4, I5. They are open-ended. That's the reason why they are not taken into consideration. So that means, how will the current flow? The current will start from positive terminal, it will move through this point A, point B, and then again it will move from this particular wire. So that means this resistance are completely out of picture. They are not participating in conduction. Right? Okay. So now let us calculate what is the current. Now the current would be, E will be what? The same? 10. Right, which is equal to, I is the current which is flowing. I want to find this current. This, let me name this it as I1. I1 into what is the resistance? Resistance is 2 ohm. It is 2 ohm. So I1 this time is nothing but what? 5 ampere. Right? So what I have done is, I have controlled the current. Yes or no? By changing this point, I have what? Controlled the current. I have changed the value of current. Earlier the current which was moving through along the circuit was 1 ampere. Now the current which is flowing through the circuit is 5 ampere. Now if I am disconnecting this circuit from point B and connecting it to point C, connecting to what? Point C. Now what would be the current flowing in the circuit? Right? The EMF will be remain the same, what? 10 volt, which is equal to what? Current I2 into, I don't know what is the current, into what is the resistance which are participating? 2 ohm plus 2 ohm. So it is nothing but what? 4 ohm. So I2 is equal to 10 by 4. So I2 this time is what? 2.5 ampere. So by connecting at different points, I am getting different values of current, right? However, what is the restriction that I am facing? The restriction that I am facing is that I can connect this particular wire only at point B, then after only at point C, then after only at point D, only at point E, only at point F. That means I have discrete values of resistance which I can connect and make them participate into the circuit. That means I will get discrete value of current, right? However, if I want my desirable current, and what if I am having a continuous variable resistance? If I am having a continuous variable resistance, I can get any desired value of current. Let's say for example, I want a current between 5 ampere, any current between 5 ampere to 2.5 ampere. In this particular case, will I be able to get it? No. Why? Because we have discrete value of resistors. Different values of resistors. That is the reason why I am getting the discrete values of current. Right? Now, instead of this, what I am doing is, I'll take a conducting material. Now, this is a conducting material. The length of this conducting material is L. And the area of cross section of this conducting material is A. And its resistivity is rho, right? So what is the resistance? Resistance is given by R is equal to rho into L by A, right? And we know the value of all this. So let's say for example the resistance of this particular conducting material is 10 ohm, right? Okay. Now replacing all this 5 resistor, I am placing this particular conducting material at this particular point. So what do I have? I have the circuit, okay, a battery, and this battery is now connected to this conducting material. Right? Okay. Now, if you ask me, what is the amount of the current which is flowing? EMF of the battery is same. Resistance of this material R is equal to what? 10 ohm. What is the current which is flowing? E is equal to I into R. E is what? 10. I is nothing but what? I don't know. R is what? 10 ohm. So what is I? I is equal to 1 ampere. Right? Okay. Now if I want a current of 2 ampere to be flowing inside this particular circuit, what am I supposed to do? I'll disconnect the circuit from this particular point and then connect it to this point, which is exactly in between the conducting material. That means this length from this point is now L by 2. Right? Now, is this length of the conductor participating in the conduction? Why? Because the current will flow like this from positive terminal to negative terminal. So it will flow from here, then it will go, and then from here, from point O, it will move through this particular wire. That means this part of the conductor is not playing any role in the conduction. Now, can you tell me what is the equivalent resistance over here? This resistance over here. We know R is equal to rho L by A. Let's say for example the new resistance is R dash. R dash is equal to rho remains the same, resistivity remains the same. L dash is now the new length. Okay, area of cross section remains the same. So now new resistance R dash is equal to rho. What is L dash? L dash is the new length which is equal to L by 2. So it comes to L by 2 into A. So that means R dash is equal to 1 by 2 rho L by A. And what is rho L by A? It is nothing but what? The resistance, this resistance which is equal to 10 ohm. So that means the new resistance R dash is now 1 by 10, which is equal to 5 ohm. Right? Okay. So that means this resistance is 5 ohm. Now let us understand, now let us calculate the current. The current is given by E is equal to I dash into R dash. So what is I dash? I dash is equal to E upon R dash. So I dash is equal to, what is E? E remains the same, which is equal to 10 volt upon R dash. The new resistance is 5 ohm. So I dash is equal to 2 ampere. So what have I done? I have controlled the current. But in this particular case, I am having a continuous variable resistor, right? If I want to connect this particular, if I want this particular point to be connected over here, any point from here to here, so here it will be what? 0 ohm. Here it will be what? 10 ohm. 0 ohm, 10 ohm. So that means I can have any resistance simply by shifting this point, connecting this point to any point from 0 to 10. I can have any amount of resistance from 0 to 10. If I am having any amount of resistance, I can have any amount of current which is flowing through the circuit. That means here my constraint of having discrete amount of current, of getting a discrete amount of current is now gone. I am free to have any amount of current, because I am having any amount of resistance. I am having a continuous variable resistance, because of which I am getting a continuous variable resistance. And this is nothing but rheostat. What is this called? A rheostat. So rheostat is a variable resistance, a continuous varying resistance. It can increase continuously or decrease continuously, so that we can control the current in continuous increasing order or in continuous decreasing order. Right? Now we will understand how is this rheostat. In the next session, we will understand how is this rheostat act as a potential divider. Right? I hope you have understood the session. Thanks a lot.